Hi everyone, and welcome to Smart City Sweden's event Bold Building, Building in Wood. We're broadcasting live from Dubai and Södra Teatern in Stockholm. Welcome. A very warm welcome to all of you digitally or visiting live in Dubai. And a warm welcome to our participants here today. My name is Susanne Rudenstam. I'm Managing Director for Swedish Wood Building Council, representing the Swedish timber building industry sector. We are experiencing a tremendous development in the wood construction industry right now, with a strong growth within the industry and a growing demand and interest from builders and developers all around the country and in the world. Multi-story housing, school, bridges, commercial buildings, office buildings, caring homes, single-family housing, and public buildings are all being built in wood. The strongest driver is, of course, the urgent need for decreasing the climate impact from the construction sector. Building in wood and substituting other materials with timber is a fast track towards the climate goal of climate neutrality. But also the need for vitalization of the construction industry and the increase of its performance and its productivity are equally strong drivers. By that, we're ready to start the first session of today, Wood, the Climate Smart Alternative. The purpose of the discussion is to talk about how wood and wood construction could represent material and solutions for the green transition for smart cities. With me here in the studio, I have Magnus Wålinder, Professor in Division of Building Materials at KTH, the Royal Institute of Technology, Agri, Senior Advisor at Resource, and Åsa Thrysin, Project Manager at IVL, Swedish Environmental Research Institute, and also specialist in life cycle assessment. There is a bold ambition set out from the Swedish government. Sweden shall be the first fossil-free welfare state. And there is also high expectations on the greater use of wood in the construction and infrastructure. The President of the European Commission, Ursula von der Leyen, said in her State of the Union address last year that we know that the construction sector can even be turned from a carbon source into a sink if organic building materials like wood and smart technologies like AI are applied. We're spending this hour talking about how wood and its material properties and how to calculate the carbon emissions in the life cycle, but also how wood comes into use in construction and the increasing development of circular use, both in the biological and the technical cycle. And I invite all of you listeners to take part in the discussion and post your questions or comments. We should perhaps also question the headline in this session, the climate smart alternative, and perhaps get some answers before the end. So, I start with asking all of you about your own personal relation to wood, starting with you, John.
Thank you very much for inviting me here today to this very future-oriented event. Wood, to me, wood is very much the forest of Sweden. And when you fly into this country, it's forest everywhere. And I've learned it's 70% of the whole area. So it's as big as Poland or Italy. And that's impressive. And then, of course, wood to me is something I have a very personal relationship to, because my home is filled with furniture and details in wood, and I really like it a lot.
You're surrounded by wood.
Yes, in many ways.
Åsa, do you have any special thought?
Yeah, I also have a very personal relationship to wood. I grow up in the forest, in the woods in Sweden, camping and hiking and picking mushrooms and everything. So for me, the smell of pine trees is very special, and have a lot of good memories with that.
Also from outdoor activities?
Yes, definitely.
And Magnus?
Well, I've been interested in wood science since the beginning of the 90s, actually. And being a professor in building materials, I think this subject is quite important and maybe not so developed as we would think in Sweden.
So what is wood, really? Could you please give us a little introduction to this material?
Well, I prepared a couple of slides here. And first of all, we can say that wood is quite a complex material. And to learn more about wood, it can be useful to look at wood at different size levels, as shown in this picture. As you can see, it's a quite different material if you compare the macro and the microscopic and molecular level. In a board, for example, you can see features like annual rings, heart and sapwood, fiber distortions. In the micro level, you can see that wood is also quite heterogeneous, varying, but a very porous material. In the cell wall structure, you can also see that it's a quite complex material made up from wood polymers like cellulose, hemicellulose, and lignin. In this next slide, what is important to remember is that wood differs a lot if we consider wood substance with actual wood. Wood is by nature a 3D printed biomaterial, often very porous structural material. In fact, wood is made to function as a tree, which is excellent structural material itself. This next picture shows such a porous structure of birch wood. Here you can see that 2/3 of wood is actually air and 1/3 is wood substance. Another thing that is important to consider is related to materials' so-called carbon cycle related to their manufacturing. And in this next slide, you can see a comparison between wood, concrete, and steel. Concrete being made up of about 10% cement, and the rest is aggregates and some water. Wood, as you know, is formed from photosynthesis, where carbon from the air, together with water and sunlight, is formed by biosynthesis to these wood polymers. In contrast to this, concrete and steel involves manufacturing processes at very high temperatures and chemical processes that emits large amounts of carbon dioxide. So if we can use wood or timber for longer periods of times, like in timber buildings, timber structures, we can actually consider wood as a carbon sink, and we can remove carbon from the air. It's a very efficient way of reducing carbon dioxide in the air. It's my opinion.
Thank you very much for a very interesting introduction to wood and the basic structure of wood. And may I also ask you, is it the same, the basic structure that you showed us, is that the same for all species around the world, or does it differ?
Well, you can say in general that softwoods like spruce and pine is less heterogeneous than hardwoods, like as I showed this birch example, and oak and maple. They are more complex in nature. They have more different types of cells, and they are actually a newer wood species evolutionary wise. It's 100 million years younger trees, the hardwoods, than the softwoods. But softwoods are very efficient. As we know, they are still here, and if we have a good strategy of replantation of our forests, I think it will be here forever.
Thank you. And I also turn to you, John, also regarding the headline, what is climate smart? And does the climate perspective get into the whole concept of sustainability?
Well, of course, climate is central to the concept of sustainable development. But before I talk about that broader concept, climate smart must today be reducing and, as Magnus was saying, creating carbon sinks, because we do need to reduce the content of climate gases, including primarily CO2 in the atmosphere. But again, climate is only one part of sustainable development. Sustainable development was actually originally made famous by the UN in the 80s and 90s, and focused very much on the development in countries that were not so developed. So there was a need to make humanity prosper without hurting the environment. And this has now today been symbolized, you can say, with the Agenda 2030, with its 17 Sustainable Development Goals. You can group them into the environmental, the social, and the economic parts, like we always have talked about them before. But now they are providing more detail about a plan for how to go further. And since I represent an innovation unit or resource funding unit, we have a very close industry perspective. And it's also my background that I worked in industry with business development. And sustainable development in this context becomes a way to future-proof your business. You need to understand what are the future demands in order to adopt to it and not go off the road, if you want. And when I learned about this concept in the 90s, I worked actually with the forest industry at the National Academy of Engineering Sciences. And it was very clear that it would be very good if the Swedish forest industry could turn from short-lived products, such as paper and packaging, to long-lived products. And we've seen a tremendous development in these 3 decades. And we now have much more construction equipment or construction materials that we've talked about. And within Resource, the organization I represent, we've funded, since 2016 when we were funded, many projects in this area, building bridges in wood, but we also have supported projects turning the resource of the Swedish forestry into textiles. So there are many ways to use the forest that we're looking forward to find new ways and support new ways of doing this. But let's continue with the construction perspective.
Yeah, because I mean, the tree, you need to use the tree in the best possible way.
Absolutely.
It's not only for construction purpose, you also use the rest streams for...
Absolutely, you can use it for chemicals, etc. And fundamentally, you can compare it somewhat to the fossil oil, in the sense that it can be used for so many different things. But we need to replace that with natural or biological resources, including forests or wood. It could also be other things, of course, from farming in other countries where they have more farmland than the 70% of forest that we have. So we will most likely focus a lot on developing many innovations based in this.
Yeah, the forest industry often says that you can do everything with the tree. The same thing that you can do with oil. That's, I guess, also you showed us, Magnus, in your overview earlier.
Yeah, I think so-called biorefinery is a possible way to actually substitute also plastics and other materials that are problematic today with very short lifespan and also gathering in the seas or oceans all over. And wood is, if it's designed correctly, it can be biodegradable too, which is quite unique property of wood.
Talking about life, long lifespan and short lifespans, I turn to you, Åsa. The life cycle perspective. Why have life cycle assessment become so important?
Well, I thought I would start off with telling you about what a life cycle assessment is. So an LCA, as it's shortened, it's a methodology how to calculate environmental impacts, and it can include all stages of a life cycle for a product or a process or whatever you want to calculate. And an LCA assesses several impact categories, where one of these categories is global warming potential, which is the measure of climate impact. So you can say easily that an LCA is a tool to analyze and illustrate ecological hotspots. And to do an LCA that you can compare to other results and reference buildings, for example, you need to know what you're declaring and calculating, so you're doing it in the same way as others do. And to do so for a building's life cycle, it is set in different stages and modules for this building. And I think I have a picture to show this, where we have stages A to D, where stage A is the product and construction stage, where raw material supply, manufacturing and transportation of materials is included. Here is also processes from the construction site included, such as waste and energy consumption on site. The next stage is the user stage, which we call for stage B of a building's life cycle. And here, for example, maintenance and refurbishments is included, and also operational energy use is included here, and this is one of the big contributors for a building's climate impact. The next stage is stage C, which is the end of life stage, where things like deconstruction and waste processing is included. And the last module, which is the D module, includes things that can be counted for beyond the building, such as reuse of materials. And this can also be included in all the other stages. If, for example, you reuse materials in the use stage in the refurbishment, you can count for that in that stage. So what we see in Sweden now, and we have for a very long time worked with energy efficiency of buildings, that the product and construction stage, as well as the energy use stage, are the big modules that contributes to the building's climate impact. So what you can use an LCA for is, for example, to provide insight in building material choices and design options, and compare structural systems to each other to see what is the best for the climate for this specific project. And what is happening in Sweden right now, that from next year, 1st of January, we will have regulation regarding climate impact. So from next year, all new buildings have to declare the climate impact from the product and construction stages. And later on, there will be tougher restrictions and regulations, but this is what we're starting with, but then we will include more life cycle stages and comparing to reference buildings and so on.
Thank you. You talked about all the different modules where different stages has their impact. Is that something that is agreed upon in all countries, or is there national varieties?
Yeah, I would say it's a EN standard that says this is the way we set a life cycle in. Of course, there could be countries that are not doing this way, but that's the most common way, I would say.
So one are agreed that this is how you measure and calculate and declare the climate impact.
Yeah, and that's also an easy way when you're declaring something. You can say we included this stage A in this calculation, and if someone else show another result, but they can include stage B as well. So then you can't compare the numbers to each other. So it's a good way to know what you included in the calculations.
So then you can actually compare different building materials, you can declare different building methods, compare different building materials and methods.
Yeah.
And make the clever choices.
Exactly.
As we speak, the COP26 in Glasgow has just started, and the focus is the need for countries to sharpen their goals on carbon emissions. In Sweden, we have been very focused on developing the energy efficiency, exactly as you touched upon, Åsa. Almost all new buildings meet the near to zero standards or are low energy buildings. So what is the most important then from a climate perspective? To focus on energy efficiency or the impact from construction and from infrastructure? How do you look upon that?
I would say both. You can't say this or this. That as we see that both these things are very important, so we need to focus more on the construction and the materials more than we have done before. But at the same time, we can't forget the energy question, that we have to also build energy efficient buildings, but also look at where does this energy come from, not that they consume less and less energy, but also what type of energy it is.
How do you look upon material producers? Are they aware of this development? Are they offering products with low climate impact to the market?
Yeah, I would say so. That more and more, of course. But if you see at the concrete industry, they have to work with these questions. Otherwise, they won't be they won't have any finance. People won't buy their product if they don't work with this issue. So I would say some industries are already catching on to this, but it's a slow sector we're working in.
So it's the power of the buyers.
Yeah, also, and the regulations as well. If you are assessing a building with an environmental assessment scheme, they can have requirements that you should use this and this type of product that have an EPD, environmental declaration, and then the producers need to produce these type of materials and these type of documents. So
what is an EPD? Sorry,
It's a product-specific environmental declaration, product declaration, which declare what this specific product has for example, climate impact, but also other environmental impacts that you measure.
So each and every component in the building has an
EPD. Yeah. So we have generic data we can use for calculating the climate impact, but then we can change the generic data into these EPDs instead to show we have chosen something better than the average product for gypsum boards, for example.
So the competition is on.
Yes.
Good. Jan, you wanted to comment, perhaps?
I have a few thoughts that come up. I agree with what Åsa says, but I think also the potential is clearly much bigger when it comes to material than energy use. But you can also look at the processes, how things are built, because we have waiting time that consume energy. We have waste because of poor planning. I'm not saying that the planning is super poor, but it can certainly be improved. But you can take it all the way also to the occupancy. How are these buildings used? And which is very important when it comes to circularity. You may talk about materials and reuse, but actual effectiveness of use is central. And if you look at offices in Sweden, they are not used super efficient. Some say even just 10% over the year, of all hours over the year, there's someone sitting at that desk. So there's many opportunities for innovation all the way from material, processes, and use. And then, of course, reuse and all these things that Åsa mentioned in the D stage. So I think there's very, very many opportunities here.
Yeah,
Well,
Magnus.
can I also comment? I also agree with what it's important to look at both energy efficiency and material manufacturing. But I think producing materials is a big energy question, because today the majority of materials are produced with high temperature, and that's a lot of energy going into that. And it should not be forgotten when we talk about materials. Materials and energy are very closely related. And it seems like Sweden, as an example, we have been very efficient producing high energy efficient buildings. But if you declare a building today, it's not as clear what the materials has caused in energy consumption or carbon dioxide or carbon footprint.
But isn't that something that is shown in the life cycle assessment? Also the embedded energy from the production phase?
Yeah,
stage?
yeah, it is. Then the energy use is calculated in climate impact in CO2 emissions, for example.
But it's not what you see when you buy a building.
No, of
today.
course.
It has to be integrated in it. And that is exactly what should be done. I think.
Yeah.
It should be similar weighing of these different components.
Yeah.
Otherwise, we are losing a very efficient tool of actually removing carbon from the air, which could be possible, actually.
Using your word.
Well, yes.
Carbon capture and storage for free. Going on. Getting back to carbon budgets and perhaps what's being discussed in Glasgow, are we ready for a more developed system for carbon budgets and carbon costs? Could it be translated into financial terms? Do we have the tools now necessary for doing that? And will the use of life cycle assessment help to get a clearer path here?
It's absolutely necessary with LCA. There's no way we can do it without it. Are we ready? No. But are we learning? Yes, all industries are learning to become sustainable or develop much more sustainably. And going back to Magnus' point about having more accurate data and understanding of what's really the most important thing in the total perspective, the banks, the financial actors will drive this, because they will have to future-proof their investments, both from a business perspective, but also because of EU legislation and directives, the taxonomy that we've heard of. So there will be a tremendous, again, development regarding data. LCA is fundamental, but you need to package it in certification schemes, etc., classification. And so
the financial industry is one of the sectors, obviously, that is hugely important to in order to drive this development. And we have seen some financial mechanisms, some financial products being launched on the market. Are they? Is there an interest from the financial industry to learn this?
Absolutely. Absolutely. And in Sweden, there are some large building companies or real estate companies that are leading in the world. And they're very quick to say that they've saved on energy and they had certification and they got better interest rates from the institutions that they borrow from. And we see this in many companies when it comes to building, that they are very keen, of course, to understand if they can get better rates. And this is part of that discussion. Climate is always central when a bank offers rebates.
True. This is absolutely necessary before we can actually turn the development to have all the major drivers working in the same direction. I also think that we should go a little bit further into circularity. I mean, designing for circularity, the use and reuse of materials and components is something that is growing. And as you mentioned, Jan, when we look upon how we use our buildings today, that's clear that there is a lot we could do in order to use them to a much higher grade. And there is also a growing demand for development of the circular and flexible use of existing buildings. How do you look upon that opportunity, perhaps Magnus, on when we build new buildings on top or refurbish the existing buildings or building extensions and so forth?
Well, I think we are good at recycling materials, at least in certain areas, but reuse of materials is more difficult because it's you need to build up some kind of I think business around that, otherwise it will never happen.
Is it possible to reuse wood?
Well, wood can be easily reused if you have, for example, smart connections between elements that can be dismantled, and that is often the case when you have connections like today. They are not very difficult to disconnect, but on the other hand, it's one thing to have the possibility, another thing that it will actually be happening a long time from now. And I think the designers, the engineers, architects that are involved in this construction industry, they need to already from the first sketch think about reuse in much higher level. And it's as important for concrete and steel, aluminum, all materials. And we are perhaps quite far away from that today. 40% of the world's waste material comes from the building sector. 40%, which is quite dramatic.
Absolutely.
Yeah.
I've seen figures on that, at least.
40%, yes. So 40% of the material that we use are just being thrown away. Can we even afford to do that? It must be very costly.
Well, if you look at steel, for example, that is not as much thrown away because it has a very high value. If you have reduced iron oxide to pure iron, it's a much lower energy in demand to reuse, remelt steel. So that's already there. But I'm thinking more about, well, concrete and wood. It's very lot of waste going out, especially if you look at a building site in Sweden. I think it's a lot of things to think about there. What could be done differently.
And I will also say that it's quite cheap to the waste is quite cheap. Like you pay someone to get rid of it, but it's not a very big cost for a building project, the waste management process in this. So the waste should be more expensive to handle waste, I would say.
So how could one use also the life cycle assessment in terms of, you have that in your last module, I guess, the demolition and the reuse. Is the reuse also taken into account in the?
Yeah, so reuse you can take in account in all stages of the life cycle. If you use it in the construction stage or the product stage, or you reuse the product, then according to EN standards, the climate impact from the manufacturing and the material input to this product is taken for the first product that this product is used. So if I reuse this door or gypsum board or so, it's zero in the next building. It can add some transportation emissions and so on, but if you reuse it in the same building and doesn't need to do anything with it, then it's zero.
So if we do that, we build with the reused material, then we're pretty close to reaching the climate neutrality.
Yeah, if you can reuse all materials when you build new buildings, then it will be a lot lower, of course. Then it will be the transportations, and maybe you have to do some repainting and so on, and fixing up some of the products.
Some of the products, yeah.
Yeah.
I think Magnus was on to something extremely important in this, and that's the business systems. Because what we want is not really to reuse materials. We want to reuse buildings, components. We've done in resource, we've done a study on the loss of value for materials. So many materials are used maybe for a short time, and then you lose 80% of the value. It could be for plastics. Even if steel, as Magnus said, has a value compared to many plastics, it would be even better if it was a steel door that was reused, or a plastic construction of some sort that is reused. But Magnus is absolutely right when it comes to business, because we don't have the marketplace. So when you want to get rid of something in your building, Magnus knows that it's in the market, and you can match the demand and the offer, so to speak, or the willingness to pay. So this is something that's extremely important, to have not only a good sales of new materials into the building process, but also a sales and market matching of used products. So this is something we're looking into, and we're also in Resource doing projects with building houses with houses, so to speak, where we can cut out a wall and put it into another building. So even if circularity is in the most simplest form, reuse of materials, avoiding waste, it's the use of products, it's the reuse of components, or the repairment and reuse, if you talk about cars, etc., that is really critical. And we talked a little bit about climate, and Magnus is absolutely right in the sense also about climate being related to the production of material and products. So we cannot just reduce energy consumption to get to the climate targets. We also need to be resource smart. So instead of talking about circularity, you can talk about resource efficiency. So that's, yeah.
How do you look upon the wood industry? Is the wood industry ready? It's obviously involves all producers of building materials, not only wood, but talking for the wood industry. Do you see any signs? I'm asking you, Magnus, but.
Well, I think what's been the problem with the wood industry is that we have a world-leading position of producing boards, exporting them all over the world. Third largest country in the world export-wise. But to take the wood material into a value-adding process and make components like cross-laminated timber or engineered wood product, that is not so developed in Sweden, actually, as we would think.
The sawmill industry has been quite focused on large volumes overseas.
Yes, and I understand that in a way, because that's how you make business. You have always made business in producing wood. It's the largest value for a forest owner is the sawn timber logs, not pulp and paper materials. So it's been a value somewhere in this chain, but I think now when we are facing this enormous climate challenges, I think we need to rethink more what is designed with wood, what is the best and most optimal way. And I think building material is one of the key areas, because it can replace very, very high carbon emitting materials and very fast. And it's already been done. In Sweden, for example, we have already substituted a lot of high carbon emitting materials. And it can go on even further. And I think it's not going to replace all materials, of course, but a higher proportion can definitely be developed. And it's a lot of business areas, which is not my area, by the way, but I think that should be a huge potential for all around the world, actually, not just Sweden, I think.
Yes, it's exciting times seeing the sawmill industry and the wood industry being transformed into a much more sophisticated supply system for buildings, where also the reuse could be an essential part. I must also ask you, Magnus, being a professor at the university, how is the interest from your students?
Well, it's increasing. I've been around for about 10 years now in my position. I've seen a drastic change. The students ask a lot more about what about timber? What about tall houses in CLT, for example? So there's a growing interest. However, I would say that traditional subjects for buildings, and choosing and the material choices has been on concrete and steel, mainly concrete. But we see a shift, and one of the areas that we are trying to develop is combining these materials. So if you have like optimal proportion of concrete, wood, and timber, all three materials can be reduced in amounts in a well-designed structure. So it's not about just using this material or that material. I think a combination of materials will always be needed. But for now, I think, unfortunately, we are a concrete country, Sweden, which may sound strange, but that's the fact. And the world is definitely a concrete world. It's been a fourfold increase of cement production the last 20 years. Fourfold.
How much sand is there in the world? How long will the sand supplies last? Have we reached peak sand?
Well, some say that regions has reached that, yes.
Okay.
So it's a critical thing that just certain qualities of sand is possible to use. And then you have another thing that adds to this problem is transportation of materials that are quite heavy.
Yeah.
I think producing the material as close as the building site as possible will always be the best, or reusing already produced materials and all that. And that is a problem when it comes to steel, for example. It's much cheaper to produce steel in China and ship it to Sweden, for example. So a lot of structures in our new buildings are actually not made from homemade materials, which could be possible with timber. And it's not just Sweden. I mean, you have a tremendous potential in the tropical regions because you have deforestation there. And if that could be turned into reforestation activities, then you would have a huge jump in carbon emissions from deforestation causing a lot of emissions to replantation, carbon storage, carbon sink effects. That together with new technology, new techniques for buildings like the tall buildings now we can see rising all over the world.
Yeah, touching upon wood and forestry, that was actually something that was agreed upon yesterday in Glasgow, having the permanent stop of deforestation in the world. And apparently, it seems so, at least, that the leaders were agreed upon that. How do you look upon that for the future of forestry? Or the use of wood, actually.
Asking me as a wood scientist, I'm not expert in forestry and biodiversity and all these quite complex science areas. But I would say in a general aspect, we have a growth of forest, increasing biomass volume in the northern hemisphere, all over the world, in North America, in Northern Europe, also some other parts. But in the mid-regions, the tropical regions, they have the opposite, which is very, very critical. And that is where I think world leaders could have a huge influence if we come together and switch that deforestation, which is caused by fuel production or food production and things like that, land change uses, into production of building materials, renewable building materials. There you have a. I've made some very simple calculations, and it's such a huge area of biomass in this region. So it could be possible to decrease carbon in the air if this is done. Now that is a vision, but I think it's something to think about. If it's not just locally here in Sweden what we can do or not, it's a global challenge.
Yeah, a prerequisite, of course, is that we have a sustainable forestry. That's basics for development of the wood construction sector.
And that means managed forests, not all, because we need to have natural forests for the biodiversity, and that's really an insurance to keep biodiversity or even increase, possibly. But it's a lot of what you're talking about, Magnus, is managing land in a way that is more productive. And so it's a matter of producing food and supporting the local economy based on maybe a combination of forestry and agriculture, as many have done and experimented with. But it's absolutely necessary to stop the deforestation that is just leaving no trees there.
No. So that we could continue to use the renewable material that we have.
Yes.
For our
It can go hand in hand, I think. I mean, agricultural development and forestry.
Yeah.
So.
But still, I'm getting back to a little bit on the circular use, and you said development of business models, and who will be the one that is kickstarting that development, or could it even be a kickstart? Is it regulation and policies, or would it come from the market itself? How do you look upon that development? We have been talking about it for quite a long time, and obviously there are sectors that has become, well, they have at least getting a little bit further down the line than the construction sector. But how do you look upon the circular use in built environment?
But generally speaking, there's a lot of interest. You asked about students. There's a lot of interest in circular business models. And that's important because it's building knowledge. I don't know specifically about the construction industry. But if we really should have the transition to a more sustainable development, the big players need to act as well. They need to become more innovative and take risks. And why would they do that? It's related to these young people, the new people that come into the companies, what they're interested in and what they drive. New CEOs, young CEOs wants to make their mark, do things differently. Owners and the financial sector will be important. So it's a difficult question, I think, to say it's that part or that section of the industry. I think it's a combination. But I would hope that the entrepreneurs and the entrepreneurship in the big, or maybe entrepreneurs in the big companies, will see these opportunities that we talk about, to go from maybe volume and low profitability to more specific construction element production with higher profitability.
Do we have those kind of innovating entrepreneurs, those new startups coming to shake the existing business logics in the construction industry? Do we have? Really?
There are some probably, but it's a very slow sector. I would say it takes time to get things going. You can see there are like pilots trying stuff and so on, but also I would say like with the actors that need to be involved. That's also the regulations that how to can we reuse this material? Do we know what's in this material chemical wise and so on? That we have trouble with that today, not knowing exactly what we're reusing, and then the regulations are not working with this fully. It's a discussion, but it's not fully there yet. I'm not an expert in the regulations, but that's what I heard from colleagues.
Yeah, so traceability and
yeah,
be able
exactly.
to
yeah, and we're working a lot with that today when we build new buildings to be tracing materials further along. But now when we want to reuse materials in old buildings, we don't really know what it is, and we have a history with using not the best materials that are hazard materials or chemicals. So that's, I think, why people also a bit skeptic, and why taking a lot of time or taking a long time to get this started.
How about the reuse of wood, getting back to you, could, Magnus, again, could one guarantee the material properties of reused wood, or is there something that is still needed when it comes to defining the qualities?
I think so. It's possible, and one of the misunderstandings about wood is that it's always problematic durability-wise. But if wood is kept dry, it actually lasts forever. If you don't have mechanical abrasion or something, you can see structures in the world that are thousands of years old. Some may have been replaced, the outer part of a building, like the facades and so on. But a timber, well dried and designed timber beam can last forever, as a metaphor. But so we could be designing future building with actually reusing all building materials if we are smart.
If we're smart.
No.
It's actually time to wrap up this discussion. We will, thank you very much, I'll say, before we go. Thank you very much for participating in this discussion. I will just ask you before we stop, what your top advice for decision makers in the built environment would be into a climate smart future. Starting with you, Magnus, again.
Increasing the proportion of timber in structures, in structural use for buildings. I think that's a very, very potential area.
Thank you. How about John?
I really like what we've been saying at COP, pioneer the possible. The Swedish delegation there says this, and I think in a business perspective, it means embrace the fact that business as usual is never going to remain the same. Business as usual is change. And in order to innovate, you need to make use of best practices, find the best materials, do the calculations, and then cooperate. Because you learn much faster if you work with others. And if you need funding and you're a Swedish organization, come to Resource, because we support particularly circular and climate-oriented projects.
And you help to find the partners for collaboration.
Yeah.
And finally, Åsa, do you have any top advice?
Yeah, I would say stricter regulations as soon as possible, because then we will get more people involved with this. Otherwise, if you don't need to, everyone won't do it.
Strict goals and strict regulations. Yeah. Thank you very much. We're now heading down to Dubai and Annika to learn whether there are any questions from the audience at you in Dubai.
Thank you, Susanne, and thank you very much to the panel for your many insights you have shared with us. I would just like to start by addressing our audience here in Dubai and encourage you to put forward any question to the panel. And you can go to my colleague sitting right here. So in the meantime, I thought I'd take the opportunity for somebody that's quite new into this subject. Is it possible to compare the climate footprint from a conventional building, just on average?
I don't know if I really understood the question, but
I guess it's could you compare two buildings with kind of the same height and width and so forth, and you could and you compare the material.
Yeah, it's possible. Today, we don't have that much information or data for this, like a reference buildings, but it's coming more and more in Sweden. We will have reference buildings in just a few months that we can actually compare it to due to this regulation. Then we will actually have something, and we have best practice benchmark buildings as well. So there are some buildings you can compare it to.
Thank you. Did you have any other question there? Annika?
So yes, I do have one from me and one from my colleagues who's online. But I wonder if the panel could just point out some different aspects of wood building that has to be in place to be considered a sustainable solution if you go abroad for a new country to start building with wood.
That, as I interpret, I read your question there, it might be of the volume of wood, or is it more from a climate declaration perspective that you're?
It's for if you have any bullet point, you know, that you should think of before you go into this.
Like a checklist, perhaps, on wood construction, yes. The starting point.
Oh, no.
And I think we already know quite well things that could be used. For example, different regions of the world have different climates, and that means that they might be different exposure to moisture or insects and termites. It's a problem that we don't have, for example, in Sweden, but that might be in the warmer regions. And therefore, knowledge about timber structures' durability is also very important, and that is should not be forgotten. But we know how to protect wood today, and it might be necessary to use some means that may look not, so beneficial. But I think that's one of the critical things. And when it comes to technical aspects on acoustics and fire protection, I think the same thing there. It's quite complicated acoustics for buildings, but we know how to develop these regions, and you have to be very thorough in the first design step to not miss out older and learn from earlier experience building with wood, like this tall house now in Skellefteå, for example.
Learn from the lessons learned from the forerunners, perhaps, within the industry. We have the knowledge already, and we're happy to share the knowledge.
Yeah. I think it's important to remember what we talked about initially. The energy consumption of any building is very, very important. And talking in the world, you can talk about heating or cooling. And cooling we should try to cool as little as possible. But another aspect that we discussed is the transparency. If you want to make something more sustainable, keep track of everything going in. It will make reuse so much easier. So energy, reuse, and then you have to remember that this is sustainable development. It's not a matter of being sustainable or not. It's not a black or white. We're going in a direction where things improve. So there are many opportunities to make things better.
But talking about transparency, then you also have the use of new technology. The digitalization is an enabler for this development.
Absolutely. It will definitely be that.
So thank you. Annika, did you have a last question?
Yes, I have one final question from the chat, and that is, building with wood is more expensive than building with concrete. So why should countries choose wood?
Perhaps a good question. Yes, Magnus.
Well, I think that is, at least in Sweden, it's old data, because recent investigations have shown that it's, for example, very easy to prefabricate elements in timber for larger structures. And that is a very cost-efficient way of producing building materials. So I've seen studies that shows it's even cheaper to build in timber structure, if that is considered. But it may be different in other parts of the world. But I think concrete is very good material, very cheap material to produce locally in many places, and there it might be a higher cost, but it's definitely not necessarily so in the future.
And I also think that the demand will change this also, that if people want a type of construction system and so on, then more people will start producing that. I guess that's also a problem that keeps the cost higher when there's less people working with wood constructions, for example.
Yes, if you do something for the first time, perhaps
Exactly.
it's
Yeah.
a bit more expensive.
Yeah, when you don't know, like traditional building systems, you know what you're doing, there's no risk into it and so on. So I guess that could be one issue as well.
Another thing is, what does it cost to emit carbon dioxide today? May not be the same in the future. It might be, as you look in the fuel sector, it has changed a lot because you are emitting a lot of non-biogenetic carbon. And that is the same thing with buildings, I think. In the future, it might cost a lot to emit carbon for buildings. So.
But of course, it's also very important to keep an eye on all the dimensions of sustainability, where the economical aspects also, both in terms of investments, but also in terms of durability, it's important.
I worked with one company that built a bar on top of a building here in Stockholm. And they told me that they used wood construction, and maybe it was not cheaper to buy, but it was much easier to handle. And it was very detailed how it was designed. It was very easy to put in place. So it saved a lot of working time. So the concept of life cycle assessment needs to be paired with life cycle cost. And that, if you bring it to the processes, is sort of what my example is discussing. But there are other examples of large corporations for brand reasons or policy reasons that want to make climate pledges. Part of that is to reside or work in buildings that are certified. And in order to do that, they're willing to pay more. And if you can have buildings like that and you get these attractive tenants, you will be appreciated by your banks. So going back again to the financial sector, they are willing to give you a rebate, obviously, or it's been proven to happen if you as a builder can certify the building as being more sustainable than others. So there are many aspects to this cost
Is that also an area also where the life cycle assessment could be used for defining a green offer?
Yeah, you can see that they already now can, like with green bonds, includes the climate aspect in it. I wouldn't say it's that developed yet, but it's starting to get there. We're working with financial actors to put new requirements, more tougher requirements on the climate impact for the green bonds, for example. And also in the, as you said, in the assessment schemes for buildings, life cycle assessments is a part of it. For example, BREEAM and LEED, both of them have it, and I guess in their schemes it will be tougher requirements further along as well, and that's a part of green bonds as well.
Do you see that we can also starting to see the consumer power, the preferences coming for consumer when it comes to buildings? I mean, in the same way that we have done in food or textiles or clothing?
I wouldn't say that much just yet. We just had a project together with like small houses, like single family houses. And what the builders see there's not really that much demand for it yet, but as in like commercial buildings, offices and so on, there we have more of a demand for it. But for like single, like the individuals, it's not that high just yet.
We actually have a question from our audience. Could we let that through?
Yes, please, go ahead.
Hi, can you hear me? My name is Peter. I'm the founder and CEO of Buildworks, a technology company, and I have a question about go-to-market strategy when it comes to wood. And increasing the value added of the wood industry. If we look at this beautiful wall, then it's a beautiful surface. But if we look at from the side, then we can see many other layers and the window and some electricity plugs. So as it actually seems to be, it's a system. It's a sandwich, right? Here, no, maybe. So the question is actually, what's the strategy for, let's say, CLT and other wood technologies when it comes to making this happening and connecting the material to the BIM technology and managing the supply chain?
So I think is it about the pavilion, your question? In general. Okay, do we have any in the panel in Stockholm that would like to answer?
I understand the question as how will the continuous development for timber building systems and products and components look like? Is that perhaps correct?
I think we're asking for strategies.
Yes, I actually have a similar question from the chat here, saying that Sweden is already building a lot of wooden houses. How are you planning on spreading the idea of timber buildings internationally? That's part of the development, I would say. And
I think these 2 days is an excellent example of how we come together and try to do that. And I think, again, cooperation is critical. So we need to find ways to pair up and do things together between, the official Sweden and the private Sweden and the different kind of companies. And I think, yeah, no, I would speculate. I don't know exactly what your plans are.
I would say that we have touched upon that. Educating young people, educating the students. Knowledge is really essential here. And then collaboration, using this existing knowledge and work with knowledge sharing, perhaps.
Yeah. But maybe if we turn the question around, we would love to get suggestions on how we can share our information. So please let us know, and we will do anything to help you.
I hope that was one of the questions, or an answer to the question. So, thank you, Annika. I think it's really time to close this session now. Thank you very much for the panels here. Magnus, Jan, Åsa, thank you very much for sharing what you're up to and your knowledge. And thank you, all of you that has been listening in, and all of you in Dubai, in the pavilion. Thank you so much for now. We will have a short break, and then we will be back in 15 minutes. So join us then. Thank you so much. Bye.